Good morning, friends. Today our topic is again squares and square roots only. Okay, squares and square roots we already discussed once again. Like suppose 2 square. 2 square value is how much? 2 into 2. That is 4. So square of 2, what we can write? Square of 2 is 4. This can be written as 2 square is equal to 4. This is a square definition. Square of 2. Square definition. Suppose it's a square root. Okay, it's a square root. Square root of 4. Square root of 4. That means square root of 4. 4 can be written as 2 into 2. So, a number is written in the form of twice. A number is multiplied by itself. 2 is multiplied by itself. So 2 into 2 is equal to, it's repeated by 2 times, 1 time will come. At the same time, root of 9, then it is 3 into 3, then it will come 3. Root of 16, so here it is 4 into 4, we can write 4. You cannot write 2 into 8 and we cannot write anything, either 2 or 8, because the number should be same. So a number is multiplied by itself, then it is called a square, and one of the factor is known as its square roots. So some examples we can see here. Root 4 is equal to 2, root 9 is equal to 3, root 416, root 25, root 36. The examples are given like this. Okay, then we'll go to the next concept. Now we'll see one live example, daily life example. We have, everybody in our house, you have your wall clock like this. Okay, numbers are given. So I changed your wall clock numbers as, okay, suppose root 4. Root 4 is 2. Okay, and suppose root 49. Root 49 is how much? 7. Okay, root 121. Root 121 is how much? 11. Root 144. Root 144 is how much? 12. So we can write this wall clock. Okay, that same wall clock we can. Okay, it is our wall clock in our house. Okay, it is our wall clock in our house. So this wall clock I made it into, okay, square root. Okay, so like this you can change your wall clock into like this. It's like a general example is given like this. By using this square root of these numbers, we made this wall clock. Like that you can discuss your numbers. Now we'll discuss some triangular numbers. Suppose 1 dot, if you keep, this is 1, right? Next, if you go to the next triangular number is 2 dots, 1. Here single dot below is 2 dots we got it. So total number of dots is 3. Next number is, see, 1, 2, 3, 1, 2, 1. So this is single dot. I think so you are following my pattern. 1, here 1, 2, total is 3. Now 1, 2, 3. 1 plus 2 is 3. 3 plus 3 is 6. Good. Your next dot is, okay, 1, 2, 3, 4. Here 3 dots are there, now 4 dots. Now next, before line is 3 dots. Next line is 2 dots. Next line is 1 dot. Then here 1, 2, 3, 3 rows are 6. Plus again 4 numbers came. So 6 plus 4. Okay, 6 plus 4 is equal to how much now? 10 dots are there. Next one will be how much? Yes, that is good. 10 plus 5, 15 dots will be there. So the numbers 1, 3, 6, 10, 15, so on. Okay, 1, 3, 6, 10, 15. Next one will be 16, 15 plus 6, 21. 21 plus 7, 28. So on. These type of numbers are called triangular numbers. Okay, what type of numbers? These are triangular numbers. So what is the relation What is the relation between triangular numbers to square numbers? What is the relation between triangular numbers to square numbers? Okay, 2 square. 2 square is how much? 4. So I place 4 dots. Now, what is the relation between triangular numbers to square numbers I am telling? So, here you see, this is 3 plus 1. Okay, what is this? 1 plus 3. 1 is your first triangular number, 3 is your second triangular number. If you add, then how much is coming? 4. So, sum of these two triangular numbers is a perfect square. Suppose 3 square. Okay, so 3 square is equal to 9. So 9 dots if you place, okay, 9 dots if you place, then you can have a doubt here. Sir, why should I draw 9 dots like this? Suppose like this, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. You can draw. But why I am drawing like this? I am finding a relation between triangular numbers to square numbers. So that's why I am writing the number into a square form, which all sides are equal. Here how many sides are there? Like in this side 3 dots are there. Here also 3 dots are there. Here also 3 dots are there. So this is the correct method to find out the relation between square numbers to triangular numbers. Now 3 square is 9. Okay, 3 square is 9. Then here, how to find out the relation between this and this? Okay, see, this is 3 numbers are there, and here it is 5 numbers are there. Here it is 3 numbers are there, here it is 5 dots are there. So here total, how many dots are there? 3 plus here how many dots are there? 3 plus 2 plus 1. 6 dots are there. So 9. So your triangular numbers. What are triangular numbers? I told 1, 3, 6, 10, so on. So next one, 4 square. 4 square is how much? 16. So 16 can be written as 1, 2, 3, 4. Okay. So like this, 4 rows I should draw. Okay. 4 rows I should draw. As per this, now the triangular numbers I am giving again. I am converting this figure into sum of two triangular numbers. Okay, here 1 plus 2 plus 3, 6. And here how many are there? 1 plus 2 plus 3 plus 4, that is 10, 16. So, finally, what conclusion we can come into here? Yes, that is sum of any two consecutive triangular numbers is a perfect square. What is that? Sum of any two triangular numbers is a perfect square. So, based on this, we have one more application also. That application is called Pascal triangle. Okay, so Blaise Pascal is a mathematician. He proposed a triangle. It is known as Pascal triangle and also as well as arithmetic triangle. What it is indicating? Okay, Pascal triangle. So the first number is 1. So in the second line is also 1 and 1. Okay, when come to the 3 to 4 rows, you will understand the concept. So extremes are all 1 all the time. Now add these two numbers in the middle two numbers. 2. Okay. Now again extremes are 1. Now add the middlemost numbers. 1 plus 2, 3. 2 plus 1, 3. Now again add the extremes. Extremes are 1 again. Now add these numbers. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Now again, add the extremes. Okay, extremes are like that. Now, 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 1 plus 4, 5. Now come to the next one. Okay, extremes are 1. Now add these two. 6. Now it is 15. It is 20. 25. Okay, like this if you see, then see this row. This is all extremes of ones. All extremes of ones. Now see the second row. What numbers you can see from here? 1, 2, 3, 4, 5, 6, so on. It will go. If you go further, it will go like this. So what numbers they are? Right. Natural numbers are counting numbers. Natural numbers are counting numbers. Now look at the third row. Okay. Again, third row. What are these third row numbers? 1, 3, 6, 10, 15. What are these numbers? You are right. That is triangular numbers. Okay? What are those? Triangular numbers. So, keep on like this. If you can write, then what will be the next one? Here, 6. If you add to it, then you will get next one. If you add to it, you will get the next one. See? 1. Extremes are 1. 1 plus 6, 7. 6 plus 15, 21. So 21 is the next triangular number. So, and if you see the procedure here, add these two, any two consecutive numbers. 15 plus 21 is 36. 36 is a 6 square. It's a perfect square. So, Pascal triangle will give you what are the triangular numbers. From the triangular numbers, we found one property of perfect squares, that is sum of any two numbers. Okay? Sum of any two triangular numbers, consecutive triangular numbers. Sorry, what is that? Sum of any two consecutive triangular numbers will give you a perfect square. Okay? Now this is the visual of the Pascal triangle. Okay? So, see the first color of this, all extremes are 1. The second color, see you can see the counting numbers. And the third color you see, that is triangular numbers. So, this is about the Pascal triangle. Pascal triangle is also known as arithmetic triangle. And use of this Pascal triangle, and many things are there involved in Pascal triangle, used in binomial theorem. And each row elements we will call it as binomial coefficients also. So when you are learning binomial theorem, you will know about that. So here the Pascal triangle for only the relation between perfect squares to triangular numbers we used. We'll go to the next topic. Okay, now the perfect square you can see in one more angle also. Perfect square. I'll tell you the perfect square one more angle. 3 square. Okay. So 3 square value is how much for you? That is 9. Right. 9. I'll place 9 dots. Okay. 9 dots. See. Now the 3 square I am writing as. Okay. How many are there? 4. This is how many are there? 2. 2, 1. What is this? 4, 2, 2, 1. So, I am seeing the 3 square, perfect square is, okay, 2 square just below one number, plus here 2 dots are there, here 2 dots are there, 1 dot is there. So, 2 square is 4, 2 plus 2 plus 1, that is 5. 4 plus 5 and 9. 4 plus 5. So, we can see like a different angle. Okay. Like suppose 4 square. Okay. 4 square you see how we can write. Okay. So, if you see the one thing in different angle, multi-angle, then you can analyze the different situations. You can innovate new things also. Now, here, 4 square. Now I am taking this is as into 3 square, 4 square is equal to 3 square. Now this is 1 3 plus here one more 3 dots and here 1 dot. Now 3 square is 9 and this is 3 plus 3 6, 6 plus 1 7, 9 plus 7 16. So 4 square is 16. Now I name it as here this picture is known as the growing squares. Okay, here we can see that different colored picture we can say. Okay, this is a just a different angle to see a perfect square. Okay, perfect square is a number. If you think like 3 square, 9 is a perfect square, 4 square, 16 is a perfect square, 25. Okay, so that's all. If you see a different angle, multi-angle, then we can see like this. So perfect squares we are discussing with triangular numbers and like different patterns we placed. Now like this, still more some more patterns we will see. Okay. Okay, now some more interesting patterns we will see now in perfect squares. Okay, that is 4 square, 16, very good. Now 34 square, 1 5 6. Okay, of course 1 6 I will write here. Okay, 34 square. Now if 334 square, what is that? 334 square. Now 111, 555, 6. Suppose 3334 square. What will come? Okay, and next if you follow this one into some 3 to 4 lines like this, if you follow the same pattern, okay, then what will come? Okay, once you write the same pattern, I wrote 4, the rest of 4 you write and you will check. Okay, now here is the result. See, the first 4 is given for you and the next 4 is also given to you here. Okay, now, okay, once compare. Okay, now one more interesting pattern for you all. 9 square, 81. Suppose 99 square, 9801. Suppose 999 square. Okay, what is that? 999 square. So 998, 001. Suppose if 4 9 squares are there, 999, 8, 000, 1. Okay, if you want, you can check in our calculator also. Okay, you will get the same answer. Okay, if the same pattern is follows, what will be the next 4 steps? 4 to 5 steps, how many you can write? You can write. So, if you write these patterns like this, you will have habituated to some pattern. Okay, good. Here is our result. Okay, this is our result. So, once compare your answer from the result. Now, one more interesting pattern. 7 square is 49. Now, 67 square, that is 4489. Okay, now 667 whole square, 667 whole square. So 444, 889. Suppose 667 whole square. Suppose 467 whole square. Like this, some 4 to 5 numbers, 4 to 5 rows. If you go, then you will understand the remaining patterns. Okay, just try. Yes, here is our result. You can compare Okay, the result with your answers. Now, some more interesting patterns are given here. Just have a look. Okay. So, if you observe the patterns, they will follow a symmetrical order. Okay. This symmetrical order is very, very important. And these patterns will make you more creative. Okay. What is the use of doing these patterns? Is to make you more creative. And to make, or you should change the intention of learning subject also. Your learning subject in the sense not only reading and by hearting. If you observe these patterns, you can create some more patterns like this. And you can have and you can enjoy the mathematics also. Okay? Bye.